billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear students, today we are taking up this new chapter, triangles, and mainly we discuss similarity of triangles in this chapter. And for triangles, congruency of triangles we have already discussed in class 9th. When are two triangles said to be congruent? So congruency we have already discussed. When two triangles are said to be congruent when all the three sides of one triangle are respectively equal to the corresponding three sides of another triangle, then two triangles are said to be congruent. This is labeled as SSS axiom. So this was the first rule you discuss in 9th class about congruency of triangles, SSS. When all the three sides of one triangle are respectively equal to the three corresponding sides of another triangle, then two triangles are said to be congruent. Second rule was when two sides and an angle. When two sides of one triangle and an angle are equal to the corresponding two sides and an angle of another triangle, then two triangles are said to be congruent, and this rule is called SAS congruency rule. Third rule, when two angles and one side of one triangle are respectively equal to the two angles and one side of another triangle, then two triangles are said to be congruent. This is called ASA or AAS rule. Fourth rule is RHS. RHS means a right angle, hypotenuse and one side of a triangle. A right angle is equivalent to right angle, RHS. A right angle and hypotenuse is equivalent to hypotenuse, and one side is equal to this. So then two triangles are said to be congruent. So there are four rules for two triangles to be congruent. First is SSS. When all the three sides of one triangle are respectively equal to the corresponding three sides of another triangle, then two triangles are said to be congruent. Second is SAS. When two sides and one angle of one triangle are respectively equal to the two sides and one angle of another triangle, then two triangles are said to be congruent. Third is ASA, or you can call it AAS congruency rule. When two angles and one side of one triangle are respectively equal to two angles and one side of another triangle, then two triangles are said to be congruent. And fourth rule is for right angles. When right angle, hypotenuse and one side of a right triangle are respectively equal to right angle, hypotenuse and one side of another triangle, then two triangles are said to be congruent. So these are four rules for congruency. And so far as the similarity of triangles are concerned, there are three rules for two triangles to be similar. For congruency of two figures, their size and shape should be equal, but for similarity, their shape should be the same. Suppose this is a circle and this is a bigger circle. These two are similar because this is circular and this is also circular, and these two round figures are similar, so we can call similar in shape, so we can call them similar figures. And in case of triangles, shape and size, both shape and size must be same, but for similarity only shape matters. So there are three rules for two figures to be congruent, especially for triangles. That is, first rule is SSS, second is SAS, third is similarity. So these are the three rules for two triangles to be similar. First is when all the three sides of one triangle are in the same ratio to the three sides of another triangle. Suppose this is ABC, this is DEF, this AB divided by DE, the ratio of these first two sides, if this is equivalent to AC divided by DF, if this is equivalent to BC divided by EF, then two triangles are said to be similar. So this is the first rule for two triangles to be similar, SSS. When all the three sides of one triangle are in the same ratio. Ratio is here important. Ratio. So second is, this is first SSS, similarity. Second is SAS. SAS, similarity. When two sides of one triangle are in the same ratio to the two sides of another triangle and one angle is equal. Suppose this is like this, ABC, and this is DEF, and this AB divided by DE, this side divided by this side is equivalent to AC divided by DF, AC divided by DF, and this angle, this which is in between them, this angle A is equivalent to angle D, then two triangles are said to be similar. This is second rule for two triangles to be similar. Third one is when AA similarity, or you can call it AAA similarity, when all angles of one triangle are respectively equal to the all angles of another triangle. So this is ABC, this is DEF. If angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F, then two triangles are said to be similar, and this is called AA similarity. You can call it AA similarity because when two angles are equal, third angle is obviously equal. So this is called AA similarity. So these are three rules for triangles to be similar: SSS, SAS, and AAA similarity. Now exercise number 6.1 is fill in the blanks. Simple. All circles are dash dash congruent or similar. All circles are similar because their shape is same. So our first blank, you will write similar, not congruent. All circles are similar. Second is all squares are similar, congruent. Again, this is similar. All squares are similar. Third part is all dash triangles are similar, isosceles equilateral. Equilateral triangles are. Equilateral means when all sides are equal, obviously their all angles are also equal, so they are similar. All equilateral triangles are similar. Fourth part is two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are proportional. If their corresponding angles are dash dash, and you will write there if their corresponding angles are equal. Second criterion is if their corresponding sides are proportional. Now question number 2 is give different examples of pair of similar figures. Similar figure is this. Similar figures. Two examples of similar figures. Similar figure means this circle and this bigger circle both are circular, so these are similar figures. And you can make two squares, all angles are equal, of the same shape, so they are similar. And non-similar figures, suppose you make a circle and a triangle, they are not similar, their shapes are different, they are not similar. So similarly, if you make a square and a triangle, these two figures are not similar, so these are not similar figures. Question number 3 is state whether the following quadrilaterals are similar or not. PQRS is a quadrilateral, and ABCD is a quadrilateral again. Now you see PS divided by AD, this is 1.5. Their ratio, the ratio of their sides is equal. This is PQRS, and this 1.5 centimeter. All sides are equal. 1.5, 1.5, 1.5. Second is again all sides are equal. This is 3 centimeter. This is 3 centimeter. This is 3 centimeter. This is 3 centimeter. This ABCD. So all sides are here equal. In this figure, all sides are also equal. This is quadrilateral. This is quadrilateral. So the ratio of the sides, this PS divided by AD, this is equivalent to 1.5 divided by 3. Similarly, PQ divided by this AB, this is equal to 1.5 divided by 3. Similarly, you can write this QR divided by BC, again 1.5 divided by 3. So ratio is same. So these figures are similar. So this was 6.1, and the next very simple. Now a very important question is of this exercise. This is a theorem, very important theorem. If a line is drawn parallel to the one of the sides of a triangle to intersect the other two sides at two distinct points, then other two sides are divided in the same ratio. This is called the basic proportionality theorem, and this was given by Thales, or you can call it Thales theorem. If a line is drawn parallel to one of the sides of a triangle to intersect the other two sides in distinct points, then you have to prove that other two sides are divided in the same ratio. Inshallah, tomorrow we shall speak of this theorem. Till then, Allah Hafiz.